MBA633 instructional video prepared by Professor Amit Tata, School of Management, George Mason University. In this clip, we will continue our discussion of counting rules and introduce combinations. We have seen in the previous video clip how to do permutations. So consider the example listed over here. You are teaching a finance class and you tell the class to pick a portfolio of 3 technology stocks from among the 8 listed on the left. Now, what is the likelihood the class will choose a portfolio consisting of Microsoft, Qualcomm, analog devices? Similar to the examples that we've been discussing before for our counting rules, the first step is trying to get a handle on the size of the sample space. How many possible outcomes do I have over here? Once I have a sense of the possible outcomes, then I'm in a position to compute the probability. So let's see how we could come up with the number of total number of outcomes for this experiment. So let's see, in how many ways could I choose the first company? Since there are 8, clearly I could choose the first company in my portfolio in 8 different ways. Now obviously I can't choose it again as my second company. So once I have chosen the first company for my portfolio, then the second company in my portfolio can be chosen in 7 different ways, and the third company can be chosen in 6 different ways. So I have 8 times 7 times 6, which is 336. But clearly, if I choose Microsoft as my first company, Qualcomm as my second, and analog devices as my third, that's no different from choosing analog devices as my first, Qualcomm as my second, and Microsoft as my third, or for that matter, choosing Qualcomm as my first, Microsoft as my second, and analog devices as my third. In other words, I could rearrange those 3 choices in any way and still come up with the same portfolio. So here you have a situation we are trying to count outcomes, but order does not matter, unlike the situation we had in permutation. Okay, so this number 336 that I had, I have to reduce it by the number of ways in which I can arrange these 3 things. These 3 companies that make up the portfolio, I can arrange them in how many ways? 3 times 2 times 1. Okay, so that's 6 different ways. Hence, the total number of outcomes, possible outcomes that I have for this experiment is simply 336 divided by 6. Okay, so if we were to write this out in longhand, this 336 is simply 8 times 7 times 6. Okay, and the denominator, the bottom one, the denominator, is simply the number of ways in which you can rearrange those 3 items, which is 3 times 2 times 1. You divide, so if you divide 8 times 7 times 6 divided by 3 times 2 times 1, you get 56. So the sample space consists of 56 outcomes, and only one of those outcomes consists of the set Microsoft, Qualcomm, analog devices. Therefore, assuming that all these outcomes are equally likely, and you can argue that they're not, but if we assume that all outcomes are equally likely, then the probability that I'm looking for is simply 1 divided by 56. Okay, now we will discuss later on situations where the likelihood of each of the outcomes is not equal, but for now let's go with this discussion, because all we're trying to show here is how do you enumerate how many outcomes there are. And the point we're trying to make is that for discrete sample spaces, the enumeration of the number of possible outcomes lies at the heart of probability calculations. Okay, so now let's take this 336 and 6 that we have, and what I'm going to do is I'm going to corrupt this number just a little bit, just like we did for permutations. I'm going to take 8 times 7 times 6, and I'm going to multiply it by 5 times 4 times 3 times 2 times 1, and in the denominator I had 3 times 2 times 1, and I'm going to multiply again by 5 times 4 times 3 times 2 times 1. Okay, oops, I made a mistake over here, so that's 4. So do you notice that all I've done is taken the number that I have over here, 56, which is 336 divided by 6, and I've simply multiplied that everything by 1, the ratio by 1, which hasn't changed anything. Now if you look at this numerator and you look at this denominator, okay, so do you see that the numerator is simply 8 factorial and the denominator is simply 3 factorial times 5 factorial. Okay, that's a shorthand. Okay, and you'll see it's useful for our purposes. So the situation where we have here, what we have here when we are trying to count is we are trying to choose 3 things out of 8, and order does not matter. When order does not matter, we use combinations. Okay, so let's say in general, if I have n things and I'm trying to choose small n items out of the large n, then the formula that I have here, if you think of the 8, 3 and 5, then the situation that I have here is n factorial in the numerator, and in the denominator I have small n factorial times capital N minus small n factorial. Okay, so this formula that you see over here is how you would go about calculating a combination. Fortunately, Excel has a built-in function for this, so let me show that to you. Is COMBIN, combination. So how many items do you have in total? I have 8 technology stocks and I'm trying to choose 3 out of that 8, and order does not matter. I should get 56, and there you have it. Here's 56 and here's the same 56 that we got manually. Okay, so you use combinations to count outcomes when order does not matter, and you use permutations to count the outcome when order does matter. And you see you're having repeated trials of the same sort of thing. So you have different experiments over here. In one experiment, like you had for the TSA lock, order does matter. Here you have a situation where you're creating a portfolio and order does not matter, and you use combinations. So permutations and combinations, and these formulas are very useful in enumerating outcomes. In general, when you're dealing with discrete sample spaces, the first step is trying to get a handle on the number of possible outcomes. Sometimes, depending on the nature of the experiment, you may not be able to use permutations and combinations depending on the specifics of the experiment. But there are a lot of situations where these counting rules, namely permutations and combinations, apply, and we will be working several problems in class that allow you to apply these 2 different types of counting rules, namely permutations and combinations.